subsection, and today we will solve the questions of number system that has been asked in UPSC CSAT 2024, right? So the first question is 222 to the power 33 plus 333 to the power 222 is divisible by which of the following numbers, right? If you look at the options, you will see that we have to check that is this number divisible by 2, is this number divisible by 3, and is this number divisible by 37, right? So let us look at the first part of the given number. So first part of the given number is 222 to the power 333. So if you wanna find the unit digit of 222 to the power 333, so we can say that the unit digit of 222 to the power 333 is equal to the unit digit of 2 to the power 333, right? So what is the cyclicity of 2? The cyclicity of 2 is 4. So what we will do? We will divide 333 by 4. And what do we get as remainder? The remainder is 1, right? Okay. So the unit digit of 222 to the power 333 is 1, right? And if you look at the second part, that is 333 to the power 222. Okay. So the unit digit of 333 to the power 222 is equal to the unit digit of 3 to the power 222, right? And we also know that the cyclicity of 3 is 4. So what do we have to do? We have to divide 222 divided by 4, right? And the remainder is 2 in this case, right? So we can say that the unit digit of 3 to the power 222 is 3 to the power 2, right? That is 9. So we can say that the unit digit of 333 to the power 222 is 9. In the same way, we can say that 222 to the power 333, the unit digit of this given number is 2 to the power 1, that is equal to 2. So we can see that the unit digit of 222 to the power 333 is 2, and we can see that 333 to the power 222, the unit digit in this case is 9, right? So if you add 2 plus 9, what will we get? We will get 11. Means we can say that the unit digit of the given number, the unit digit of the given number is 1, right? So do you know that if the unit digit of a given number is 1, then we can say that that number is not divisible by 2. So what is the divisibility rule of 2? Suppose if there is a number A, B, C, D, E, F, right? And F is the unit digit of this number A, B, C, D, E, F. So the F has to be either 0 or 2 or 4 or 6 or 8. And in this case, we can see that the unit digit of the given number is 1, means this number is not divisible by 2, right? And if this number is not divisible by 2, so we have to check that in which of the options it is given that it is not divisible by 2. So if you look at the first option, it is given that the given number is divisible by 2 and 3 but not 37. But what we have got here, that the given number is not divisible by 2. So the first option is incorrect, right? So let us look at the second option. It is given that this number is divisible by 3 and 37 but not 2. So if you don't look at option C and D, we can say that probably this option is correct. Probably this option is correct. But if you look at third option, you will see that it is again given that the given number is divisible by 2 and 37 but not 3, right? But we have found that the given number is not divisible by 2 because the unit digit is 1, right? So if the unit digit of any number is 1, means that number is not divisible by 2. So we can say that the given number is not divisible by 2. So third option is again incorrect here, right? So if you look at option D, we can see that it is given that the given number is divisible by 2, 3 and 37. But what did we have find here? That the given number is not divisible by 2. So again option D is incorrect. So what is the remaining option? The remaining option is B, and the B option is correct. So if you can observe the unit digit and if you can eliminate few options, we can easily find that the given number is divisible by 3 and 37 but not 2. So by eliminating options, we only have one option. That option is correct. So sometimes we can also apply this kind of approach to solve this kind of question, right? Okay. So what is the general approach? If we try to solve this question by general approach, so what we have to do? Okay. So we can write it as 2 into 111 to the power 333 plus 3 into 111 to the power 222, right? So what can we do here? We can take 111 to the power 222 as common, right? So what can we write here? 2 to the power 333 into 111 to the power 111 plus we can write 3 to the power 222. Okay, are you getting this point? That we have taken 111 to the power 222 as common, right? We can write 111 as 3 into 37, right, to the power 222, and we can write this part as it is as same as we have written above, right? 2 to the power 333 into 111 to the power 111 plus 3 to the power 222. So if you focus at this part, if you look at this part, we can easily say that this number is divisible by 3 and this number is divisible by 37, right? Means a given number is divisible by 3 and 37. So we have to check that is the given number divisible by 2. So if you look at this part, we can see that this part is an even number, right? 2 to the power 333 is an even number. So even if you multiply this number with 111 to the power 111, again this part is an even number. So this part is divisible by 2. And if you look at this part, you can see that 3 to the power 222 is an odd number. So we can say that this part is not divisible by 2, right? So if this part is not divisible by 2, we can say that the entire number, the given number, is not divisible by 2, right? So what is the correct option? The correct option is B. So the given number is divisible by 3 and 37 but not 2, right? Let us look at the second question, right? So what is the question? Consider the following statements in respect of the sum s equal to x plus y plus z, where x, y and z are distinct prime numbers, each less than 10. The unit digit of s can be 0, the unit digit of s can be 9, the unit digit of s can be 5. Which of the statements given above are correct? Means we have to find that which of these three statements are correct. So if it is given that x, y and z are distinct prime numbers, each less than 10. So we can say that x, y, z can be 2, 3, 5, 7, right? The possible values of x, y and z are 2, 3, 5 and 7, right? So we have to find out the possible values of s equal to x plus y plus z, right? And we have to keep in mind that x, y and z are distinct prime numbers. What does it say? It says that if you take the value of x equal to 2, means you can't take the value of y and z equal to 2, means because it is given that x, y and z are distinct prime numbers, means the values of x, y and z are distinct, right? The values of x, y and z are different. So if x equal to x plus y plus z, so if you look at this part, we can say that the possible values of s are 2 plus 3 plus 5 equal to 10, right? The another possible value of s are 2 plus 3 plus 7 equal to 12. The another possible value of s are 2 plus 5 plus 7 equal to 14 and 3 plus 5 plus 7 equal to 15, right? And what are the statements? The statement first says the unit digit of s can be 0. We can see that in the first case the unit digit of 10 is 0. So the unit digit of s can be 0, means the statement 1 is correct, right? And in the second statement it is given that the unit digit of s can be 9. If you look at the 4 possible values of s, are you able to see that any of the given numbers doesn't have unit digit 9, right? The unit digit of the possible values of S are 0, 2, 4 or 5, means the second statement is incorrect, right? The third statement says that the unit digit of S can be 5. We can see that in the fourth case, the unit digit of S is 5, means the third statement is correct, means statement 1 and statement 3 are correct, right? So what is the right answer in this case? The right answer is C option, means 1 and 3 only, right? Even if you don't go through these possible values of S, so what can you see? The minimum possible value of S is 10. 2 plus 3 plus 5 is 10, right? And the maximum possible value of S is 3 plus 5 plus 7, that is 15, right? If you look at the first statement 1, the unit digit of S can be 0, means you can immediately think that statement 1 is correct, because the minimum possible value of S is 10, and if S is equal to 10, means the unit digit of S is 0 in this case, means we can see that statement 1 is correct, right? If you look at the statement 2, it is given the unit digit of S can be 9, means can we say that if the unit digit of S is 9, means S can be either 9 or S can be 19, right? Or S can be 29, then only it is possible that the unit digit of S is 9. So if you look at the minimum value of S is 10, right? Means in any of the possible cases, the possible value of S is not 9, because the minimum possible value of S is 10, right? In the second case, we can see that if the unit digit of S has to be 19, means S has to be 19, and you can see that the maximum possible value of S is 15, right? It means that the value of S is never gonna be equal to 19, means statement 2 are incorrect. So you can see that there is only one option C where it is given that 1 and 3 statements are correct, right? So even if you go through this process, you can see that we don't have to check about other option statement third, right? You don't have to check about statement third, so you can mark option C as the correct answer. Okay, I hope that your concepts are getting clear, right? Let us look at this question. What is the rightmost digit preceding the zeros in the value of 30 to the power 30? We can write 30 to the power 30 is equal to 3 into 10 to the power 30, right? We can write it again as 3 to the power 30 into 10 to the power 30, right? So we can see that the value of 10 to the power 30 will only give zeros for the value of 30 to the power 30, right? Okay, so what is the rightmost digit preceding the zeros in the value of 30 to the power 30 is gonna be equal to the unit digit of 3 to the power 30, because 10 to the power 30 will only add zeros in this value, right? So we have to find out the unit digit of 3 to the power 30, right? And we know that the cyclicity of 3 is 4, right? So we are going to divide 30 by 4, and if we divide the number 30 by 4, the remainder is 2. So we can see that, we can say that the unit digit of 3 to the power 30 is going to be the unit digit of 3 to the power 2, and that is equal to 9, means 9 is the rightmost digit preceding the zeros in the value of 30 to the power 30, right? So what is the correct answer? The correct answer is option D, 9, right? Okay, let us look at another question, right? 32 to the power 5 plus 2 to the power 27 is divisible by. So the options are 3, 7, 10, 11, right? So if you look at the unit digit of 32 to the power 5, so the unit digit of 32 to the power 5 is equal to the unit digit of 2 to the power 5, and we can see that the unit digit of 2 to the power 5 is gonna be equal to 2. We directly know that 2 to the power 5 equal to 32, right? Even if you don't know the value of 2 to the power 5 is equal to 32, you can what we can do? we know that the cyclicity of 2 is 4, so we will divide 5 by 4, so remainder is equal to 1. So the unit digit of 2 to the power 5 is equal to the unit digit of 2 to the power 1, and that is 2, right? Okay, so the unit digit of 32 to the power 5 is gonna be equal to 2. If you look at this part, 2 to the power 27, right? So the unit digit of 2 to the power 27 is gonna be equal to, so we know that the cyclicity of 2 is 4, so we will divide 27 by 4, means remainder equal to what? Remainder is 3 in this case. So the unit digit of 2 to the power 27 is equal to the unit digit of 2 to the power 3, and that is equal to 8. So the unit digit of 2 to the power 27 is 8, means if we add the unit digit of these two numbers, what are we gonna get? We are gonna get 10, means we can see that the unit digit of the given value is 0, right? If a number has 0 as unit digit, right, means it is clear that that number is definitely divisible by 10, right? So the option C is correct, right? So if the options are probably 5, 2, then we can be confused, right? But the options are 3, 7, 10 and 11. So if the unit digit is 0, we are damn sure that this number is gonna be divisible by 10. And in UPSC CSAT, there is only gonna be one option correct in UPSC CSAT, right? If you look at these 4 options, right, we don't have any another option. But if you wanna solve this question by basic method, so we can write it as 2 to the power 5 to the power 5 plus 2 to the power 27. What did we do here? We write 32 equal to 2 to the power 5. I hope that this thing is very clear to you, right? So what we can do here, we can do 2 to the power 5 into 5 plus 2 to the power 27. Why did I multiply this 5 with this 5? We know that a to the power m to the power n equal to a to the power m into n, right? Okay, so it is 2 to the power 25 plus 2 to the power 27, right? We can write it as 2 to the power 25 as common plus 1 plus 2 to the power 2, right? We can write it as 2 to the power 25 into 1 plus 2 square, means 5, right? Means we can write it as 2 to the power 24 into 2 to the power 1 into 5. We can write it as 2 to the power 24 into 10, right? So we can clearly see that this number is divisible by 10, right? So what is the correct option for this question? That is option C, right? Okay, so let us meet in another lecture where we will solve more questions that has been asked in UPSC CSAT, and we will learn amazing ways to tackle the questions of UPSC CSAT in incoming lectures, right? Thank you.